KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, in this class we are going to discuss about change of state. Initially, we are going to concentrate to discuss change of state. This is change of state. After completion of that, based on the change of state, we are going to define one important physical quantity, that is latent heat. That is latent heat. Okay, va? Right. First we are going to talk about change of state. Change of state, right? Okay. That's what you know already in many times in our, see from lower classes onwards, what is meant by change of state, right? So matter is available in three states, no? Solid, liquid and gaseous. Okay, va? Right. See the general, see with the, even with our sensor, generally we can observe that, you know, when the surroundings temperature is high, suppose for example ice cubes become water when the surroundings temperature is high. Similarly, the water becomes vapor when the surroundings temperature is going to reach 100 degrees centigrade. This is what the usual observation, right? Not only ice, water, steam, anything. For example, you take iron. You can see the molten state of iron also, but the required temperature is high. Similarly, in our surroundings also, see in many of the situations, for example, coconut oil, right? See sometimes, especially in case of January, December to 25th onwards, you know, the winter is giving a lot of cool, no? At the time, if you see that coconut oil in our, that is what, tin, you know, which will become like a solid, right? Similarly, ghee, right? That is what you can see, semi-solid and somewhat liquid, right? Like that. So, why I am saying all these examples means, the change of state is the natural phenomena and very common phenomena what we experienced in our daily life. Okay, right. But here the important thing what I want to say is, while talking about change of state, we need to define, we need to discuss most important points. For example, what is fusion, what is melting point, what is boiling point, okay, and what is regulation, and then what is vaporization, what is the boiling point, right, and what is sublimation. These are all we have to discuss, right? Okay. Among all those things, some of the things you may already know. For example, what is boiling point means you know very well. What is melting point means you know very well. But regarding the change of state, these all the things are maintaining a key role, and these are the things we have to discuss because these are the things which gives us the physical state of a body is possible, whether it is solid or liquid, up to what temperature. For example, if you take the ice, right, so if the temperature is 0 degrees centigrade or less than 0 degrees centigrade, only you can see ice cubes, ice. Suppose if the temperature is increasing more than 0 degrees centigrade, like for example 20 degrees centigrade, 30 degrees centigrade, like that means you can't see the piece of ice cube, that you can see water, that is a liquid form of ice, right? Similarly, when the surroundings temperature is more than 100 degrees centigrade, suppose you are going to keep a container having certain amount of water on the stove and you start to heat, then what will happen? Slowly the temperature is going to increase. See, automatically the water becomes a vapor. There you can see only the vapor state, you can't see the liquid state. That's what I am saying, right? So every matter, whether it is solid or liquid or gaseous, there is a range of temperature. Between that range of temperature only, it behaves like a solid, it behaves like a liquid, it behaves like a gaseous, right? That's what I want to say, right? See here, see here. Matter normally exists in three states: solid, liquid and gas, right? A transition from one of these states to another, a transition from one of these states, either from solid to liquid or from liquid to gaseous, or that is whatever it may be. A transition from one of these states to another state is called a change of state. A transition from one of these states to another is called a change of state. Is called a change of state, right? Two common changes of states are solid to liquid and liquid to gas. Is it right or not? You just think of with your own sense, with your own brain, right? See, two common changes of states are solid to liquid and liquid to gas, and vice versa, because the gas to liquid also, liquid to solid also, right? These changes can occur only when the exchange of heat takes place between the substance and its surroundings. These changes can occur when the exchange of heat takes place between the substance and its surroundings. Okay, right? Now, to study the changes, to study the change of state, to study the change of state on heating, to study the change of state on heating or cooling, see the following activity. Right now we are going to discuss one activity, right? See here, this is what here. See, before going to see this activity, I want to tell you some of the important points. That is what is meant by fusion. What is meant by fusion? Okay, right. See, what is meant by fusion? The change of state from solid to liquid, is called melting. That's what you know. And from liquid to solid is called fusion, right? I will repeat once again. See, the change of state from solid to liquid is called melting, and from liquid to solid is called fusion. Liquid to solid is called fusion. Okay, right. It is observed that the temperature remains constant until the entire amount of the solid substance melts. It is observed that the temperature remains constant until the entire amount of the solid substance melts. So what he is saying, when there is a change of state, the temperature rising should not take place. When there is a change of state, right, temperature increase, that is what the increase in temperature will not, this is, I am not saying, it is a natural thing, natural consequence, natural phenomena, right? So we observed that the temperature remains constant until the entire amount of the solid substance melts. Okay, right? Now, both the solid and liquid states of the substance coexist in thermal equilibrium during the change of states from solid to liquid. Right? I will repeat once again. Both the solid and liquid states of the substance coexist in thermal equilibrium during the change of states from solid to liquid. Right? See, the temperature at which the solid and the liquid states of the substance in thermal equilibrium with each other is called as melting point. Right? I will repeat once again. The temperature at which the solid and liquid states of the substance in thermal equilibrium with each other is called its melting point. Okay, that is one thing. And next thing, it is characteristics of the substance. It also depends on pressure, right? So the melting point also depends upon the pressure. The game of skating, right? That is right. Now, the melting point of a substance at standard atmospheric pressure. The melting point of a substance at standard atmospheric pressure is called its normal melting point. is called its normal melting point. Okay, right. See, now we are going to discuss, that is what one activity to understand the process of melting of ice. To understand the process of melting of ice. Okay, right. See, here we took a slab of ice. Here we took a slab of ice, and there is a metallic wire and fixed two blocks. See, this is the metallic wire. There are two blocks. Okay, right. If you put the wire over the slab, this is the slab. No, so put the wire over the slab. You will observe that the wire will pass. You will observe that the wire passes through the ice slab. This happens due to the fact that just below the wire, ice melts at lower temperature. Just below the wire, ice melts at lower temperature due to increase in pressure. Right here, whatever the ice is present here, that will be melt. That will be melt due to the increase in pressure. Okay, right. Full stop. When the wire has passed, water above the wire freezes again. When the wire has passed, water above the wire freezes again. This is the important point, right? Now, the wire passes through the slab and the slab does not split. The wire passes through the slab and slab does not split. This phenomena of refreezing is called as regulation, right? See, first we kept a wire. See, the piece of ice which is under the wire first became as water because of pressure of the wire, right? After that, when you remove the wire, see, the same water will become like ice, right? That is why, because it is called as refreezing. That refreezing, right? That phenomena of refreezing is called as regulation, right? Okay. Skating is possible on snow. Skating is possible on snow due to the formation of water below the skates. Due to the formation of water below the skates, right? Water is formed due to the increase of pressure and it acts as a lubricant, right? Water is formed due to the increase of pressure and it acts as a lubricant, right? See here. Now, after the whole of ice gets converted into water, and as we continue further heating, we shall see that the temperature begins to rise. See, the temperature keeps on rising till it reaches nearly 100 degrees centigrade, when it again becomes steady. The heat supplied is now being utilized to change water from liquid state, to vapor or gaseous state, right? See, finally he is coming to the same point what we already discussed. That point is, when a change of state takes place for matter, the temperature, the increasing in temperature, the rising temperature, the temperature remains constant. That is the only point he is repeating again. Okay, right. If the change of state from liquid to vapor is called as vaporization. That's what you already know. And one more point is, right, the temperature at which the liquid and the vapor states, okay, the temperature at which the liquid and the vapor states of the substance coexist is called as boiling point. See, already we discussed what is melting point. What is melting point? The temperature at which the solid and the liquid states of the substance coexist means there we are getting melting point. Similarly, when the liquid and the vapor states are getting coexist means that is there we are getting boiling point. Okay, that's what, right. Now, see, by taking one more activity, that is what, by taking round bottom flask, right, more than half filled with water, right, and with the help of burner, stand, we are going to discuss some other activity. There we are observing the vaporization. See, here already we observed from solid to liquid, but here we are going to observe from liquid to gaseous. Okay, right. See here, take a round bottom flask more than half filled with water, keep it over a burner and fix thermometer and steam outlet through the cork of the flask, right. As water gets, it is a small activity, already you know that, but I am going to repeat once again just to discuss vaporization process. Okay, right. Here, as water gets heated in the flask, note first that the air which was dissolved in water, right? See that water, that air which was dissolved in water first will come out as small bubbles. Okay, right? Later, after that, bubbles of steam will form at the bottom. Bubbles of steam will form at the bottom, but as they rise to the cooler water, near the top, they condense and disappear, right? That is what happening there, right? Finally, as the temperature of the entire mass of the water reaches to 100 degrees centigrade, these bubbles, that is what steam bubbles, reach the surface, and the boiling is said to occur. Okay, right? Now, the steam in the flask may not be visible because as it comes out of the flask, it condenses as tiny droplets of water, right? And gives us like a foggy appearance or foggy visibility, right? Okay, now see, if now the steam outlet is closed for a few seconds to increase the pressure of the flask, then what will happen? The boiling will stops, right? You will notice that the boiling will stops. See, more heat would be required to rise the temperature before boiling begins again. This boiling point increase with increase in pressure. This is the important point we have to note down. The boiling point increases with the increase in pressure, right? That is, okay. Now, suppose for example, now you remove the burner. Allow water to cool to about 80 degrees centigrade. Remove the thermometer and steam outlet. Close the flask with a airtight cork and keep the flask turned upside down on the stand. What will happen? Pour ice cold water on the flask. See, water vapors in the flask condense, reducing the pressure on the water surface inside the flask. So what will happen finally? Water begins to boil again, now at a lower temperature. That's why what can we say? The boiling point decreases with the decrease in pressure. So you please keep in mind, through this activity we observed the vaporization process, it's okay, and we are getting two important points. One is the boiling point increases with increase in pressure, the boiling point decreases with decrease in pressure. Okay, right. Now this explains why cooking is difficult on hills at high altitudes where the atmospheric pressure is lower. Okay, that is. And we can say one more point here, that is the boiling point of a substance at standard atmospheric pressure is called its normal boiling point. And one more application I can say, that is what you can cook speedily with the help of pressure cooker. The reason is this one, the important points what I told you. Okay, right. And now one more thing, the change from solid state to vapor state without passing through the liquid state is called sublimation. The change, right? The change state from solid to vapor state without the change of state from solid to vapor or from solid state to vapor state without passing through the liquid state is called sublimation. The camphor, right? So that is what you can say like a example, right? So it has to go directly from solid to gases. Okay, that's what you can say the example of sublimation. Okay, right. Now we are going to discuss next important physical quantity, latent heat. What is the meaning of latent? Which is what like hide. Hide and seek games the children are playing when they were when they were at the age of at the age of 5th, when they are studying 5th class or 6th class, right? The peoples are playing, right? Children are also playing. Sometimes elders also they play, that will be different. Okay. See, what I am saying is latent meaning is hide. See, latent heat. Okay, see here. The heat required during a change of state depends upon the heat of transformation and the mass of the substance. The heat required during a change of state depends upon the heat of transformation and the mass of the substance. That is what I can say. The mass of the substance undergoing a change of state. Okay, right. Okay. Just now I told you one point before I think 5 minutes. When a substance is changing its state, then the temperature remains constant. Okay, right. If see here, For example, you just consider the change of state from solid to liquid, right? See, suppose there are ice cubes. Ice cubes has to become to water. You know, we need certain amount of energy, no? Right? You are going to heat the ice cubes. Then what will happen? Ice becomes to water. But here the important observation is, you know, for example, you take certain amount of ice cubes, certain number of ice cubes into a beaker, and you start to heat the beaker, right? See, slowly what will happen? First, the ice cubes temperature, the temperature of the ice cubes increases from -10 to 0. Okay. After what will happen? Every ice cubes try to become to the water. See, ice cubes becomes to the water. The important point we have to notice here is, right? See, unless the total number of ice cubes becomes into the water, there will be no increase in the temperature from 0 degree centigrade. Once the temperature of the once all the ice cubes converts into the water, then the temperature starts to increase from 0 degree centigrade to some other value. The same scene will repeat regarding liquid vapor. Okay, for example, water vapor, right? The same situation. See, when the temperature of the water attaining 100 degrees centigrade, then boiling starts, right? Okay, depends upon the atmospheric pressure, it's okay, right? See, unless the total number of water molecule converts into the vapor molecules, there will be no increase in the temperature. The temperature is 100 degrees centigrade only. Okay, that is right. So, if you understood these two situations, now you can easily understand what is latent heat. Okay, right. See, latent heat is the amount of heat energy required per unit mass of substance. Latent heat is the amount of heat energy required per unit mass of substance to change its state. For example, if you take a solid material, a solid matter, the amount of heat energy required to change its state from solid to liquid, without increasing the temperature is called as latent heat of fusion. Similarly, the amount of heat energy required per unit mass of substance to change its state from liquid to gaseous is called as latent heat of vaporization. Okay, right. That is what I didn't write here, but because of having three states, solid, liquid, gaseous, we have two quantities. One is latent heat of fusion, another one is latent heat of vaporization. Okay, right. And mathematical formula you can write for latent heat as L is equal to Q by M. L is known as latent heat and is a characteristic of the substance, and the SI unit is joule per kg. Okay, and this is the graph. Here you can see regarding the here it is like on x-axis we have taken heat energy, and on y-axis we have taken temperature. See, when there is a melting takes place, the temperature is 0 only. There is no increase in the temperature. Here ice cubes, that is what solid phase ice, and it is what liquid phase LP water. See, it is solid phase, it is liquid phase, but there is a gap. So here the solid is converting into liquid. At the time there is no increase in the temperature. Similarly here also, this is what water and this is the steam, right? See, here there is a gap. So here what will happen? See, the liquid is converting into gas. There is no increase in the temperature. That is what 100 degrees centigrade. So this is what you can understand from this graph. Okay, that is. And we also have some table in our textbook to discuss that is what the melting point and latent heat of fusion and latent heat of vaporization with the boiling point also. For example, if we take ethyl alcohol, melting point is -114 degrees centigrade. Latent heat of fusion is 1 into 10 to the power of 5 joule per kg. Boiling point is 78 degrees centigrade. Latent heat of vaporization is 8.5 into 10 to the power of 5 joule per kg. Suppose if you take mercury, that is -39 degrees centigrade is the melting point. Latent heat of fusion is 0.12 joule, 0.12 into 10 to the power of 5 joule per kg. If you take boiling point, it is 357 degrees centigrade for mercury. And if you take latent heat of vaporization, it will be 2.7 into 10 to the power of 5. 2.7 into 10 to the power of 5 joule per kg. Okay, so like that we can see the latent heat of vaporization and latent heat of fission values for different substances like ethyl alcohol, gold, lead, mercury, nitrogen, oxygen and water. Not only the things, the substances what given here, but remaining substances also, right? But conceptually we have to understand what is the latent heat and what is the latent heat of fission and what is the latent heat of vaporization. On what factors it depends, what is the formula, what is the SI unit, what is the SI unit, and if you want you can know some other information also, right? So this is the major information we have to discuss about the latent heat. Okay, for example, some other information is what? Latent heat is a scalar quantity because heat is a form of energy, no? Heat is a form of energy, that's why latent heat means which is a scalar quantity. Okay, right? So in this class we discussed, right, change of state. See, when a matter is changing its state from when matter is changing its state from one form of, that is what, one state to another state, what's happening there, that's what we discussed. Meanwhile we discussed the important terminology like what is that, regulation, sublimation, melting point, boiling point, etc., right? So many of we discussed, and after completion of that we came to discuss what is latent heat. Okay, and the definition, on what factors it depends, and the formula, right? See, what factors means what? It is a characteristic of the substance, that's enough. This is the important sentence regarding the nature of latent heat. Nature of latent heat means what, ma? Latent heat is a physical quantity. Okay, right? See, nature of the substance, that is what, characteristics of the substance, and formula, SI unit, and the graph which gives a lot of information about the latent heat regarding the three states of matter: solid, liquid and gaseous. Okay, right? So in our next class we will continue with the next continuation example problems, right? That is what, example 11.4 and example 11.5. Okay, right? Thank you.